Hello, let's continue our Sudoku adventure with Blue Side A by ChinStrap. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these blue lines in the grid. These are region sum lines. So the way these work is the lines, when they cross a box border, are segmented by that border. So whenever they cross a border, even if they re-enter a box, which I don't think happens in this puzzle, whenever they cross a border, it segments the line. So this is a single segment, and then we start a new segment here, and this is a next segment. So within the same line, segments must sum to the same value. So this sum, whatever it is the same as this sum. So if this was, say, 1, 2, 3, 6, that adds to 12. That would mean these three also add to 12. But it doesn't mean that, it doesn't mean these add to 12. It doesn't have to. Cool. And we also have crop key pairs here. So digits separated by a white dot are consecutive. So if this was 2, this could be 1 or 3. Digits separated by a black dot have a 1 to 2 ratio, meaning 1 is exactly double the other. So if this was a 2, this could be a 1, because 2 is double 1. Or this could be 4, because 4 is double 2. Not all of them are necessarily given. That just means if I had, say, 2, 4 here, there could have been a black dot. There isn't. That's perfectly fine. We're allowed to place a 2 and a 4 next to each other, even if they're not on black dot. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so we have some gimmies here because this segment is 3 long and this is 1 long. So we're basically saying these sum to whatever this digit is. Now the minimum I can put here is 1, 2, 3. And 1 plus 2 plus 3 is 6, which is the biggest I can put here. So that's what we must do. 6 goes with 5 across a white dot. Now these are 4, 5, 6. So this is just a clone here. This is the same sum as this. And so they're just the same digit. So 4, 5, 6 goes there. Let's see. Next to a 4, 5, 6 is a 3, 4, 5, 6. And actually that's what this would be anyway. Because this could be a 1, 2. Which would make that add to 3. So that works. Okay, so what's going on here? These are from... We need a 4 on here for sure. That means that's not 4 for the box. This is minimum 10. What's the maximum here? 4, 5, 6 is 12. No, 15. Not 12. 4, 5, 6 is 15. So this is anywhere between 10 and 15, which is not super helpful. What about here or here? Sum to these. These 3 sum to these 2. That's not very restricted. These can't have a 6 on them though. So that might be restrictive enough. So the maximum here is 4, 5, which is 9. The minimum here is 6. So we're somewhere between 6 and 9. Ooh, somewhere between 6 and 9. That's not great. Unfortunately, 9 is that cutoff where we don't need a 1 anymore. We could do 2, 3, 4 on here, and that would be fine. This would add to 9. That's how we'd have to do it, but it's possible. I don't know if this black dot interferes with that. This was 2, 3, 4. It really doesn't. 3, 6 would work, for example. So, what do we do about this? This is also 3, 4, 5, 6. Oh, it's not 5, 6. So 3, 4 removes 6 from here. Okay. And so there must be a 4 on here. This is either 3, 4 or 4, 5. So this cannot be 4, leaving 5, 6 only, meaning that can't be 3. And that's a 5, 6 pair. Interesting. And so that comes back down, making this 4 and 3. Okay, progress. That's also a 4 because it's a clone. So up here we need a 5, 6, and a 1, 2, 3. Ooh. So this cannot add to 6 anymore. I wonder if there's something easier to think about. Or, I wanted to look at this column. 1, 2 is what's left, and this is 1, 2, 4. There's a 4 in one of these two. This has the 5 or 6. I mean, we can't put a 6 on here. That's all we really learned. We already knew that, though. In fact, where's 6 go in this box? Ooh, no, I don't know if I can say that. I know 6 doesn't go down here. But I think I could put a 6 on this sum easily, because this is a bigger sum. Yeah. So you almost want a 6. All right, never mind about that. This This sum here doesn't have a 4 on it. This 4 sees the entire thing. Can I do anything about that? Does that help me? So the thing that I know about this sum is that it's two different ways to sum to the same thing, right? If I try to do, for example, 1, 2, adding to 3, this would also have to be 1, 2, because there's only one way to add to 3. And now I have too many 1, 2s in this column. So I need two different ways to add to it. So we're not adding to 3. We're not adding to 4, which can only be 1, 3. Now, we could have normally added to 5, but the 4 is gone. And to add to 5, you need to do 1, 5. Oh, sorry, to add to 5, you need to do 1, 4 or 2, 3. And 1, 4 is gone now because 4 is not on here at all. If we wanted to add to 6, we also can't because 6 would be 1, 5, 2, 4. And again, can't put 4 on there. So we add to at least 7. Once we get into 7, there's now at least 3 ways to add to it. And the max we can add to is 11. So I'm not sure how much that helps, but it means it adds to a pretty big amount. But we could still put a 1 on it. We could do 1, 6 with 2, 5. And that would work fine. So we haven't quite excluded 1 yet, unless we can prove it's not 7. Interesting. So we know what this total sum is. I wonder if that's helpful. Because we have this 4 placed. So we know the whole box adds to 21. 1 through 6 adds to 21. We subtract 4 from that, then we get 17. So these sum to 17 in total. And we know this is at least 7, which makes this at most 10. At most 10. We already knew it was at most 9, so that's not super helpful. Okay, well, we know this is at most 9. So this is at least 8. And if it's at least 8, we can remove the 1. Okay, let me go over that again. So the entire box sums to 21. Minus 4 is 17. You remember that we proved that this is at least 9. Because, sorry, at most 9. Because this maxes out at 4, 5. So even if this contributed its absolute maximum of 9, that means that these need to contribute at least 8 in order to get us to 17. If this gets smaller, this has to contribute more. So as a result, these add to at least 8, and you cannot use a 1 in a sum to 8 because you have to do 1, 7. 7's on the puzzle. So there is no 1 on this line. And there's actually a range here because we know that this can add to 9 or 8, but it can't add to 7. Because it would need the 4. 3 digits adding to 7 is 1, 2, 4 only. So can it add to 6? It's actually really the question here. Well, let's think about this. If this added to 6, in order to get to 17, this would add to 11. So, and there's only one way to add to 11, which is 5, 6, which we can't do. So once we get to the higher digits, we also have only 1 or 2 ways to add to it. So we can't be 10 or 11. So we max out at 9. So this adds to 8 or 9. And then this is the other 8 or 9. That's what we've proven. I feel like I spent a very long time on that. But this adds to 8 or 9. So if it added to 8, we can't do 1, 7. So we could be 2, 6 or 3, 5. That would work. If we wanted to add to 9, we can't do 1, 8 or 2, 7. So we'd be 3, 6 or 4, 5. And there's no 4 on here. So we can't do 9. There's only 2 ways to add to 9. 3, 6, 4, 5, and 4 is gone. So this adds to 8. There's only 2 ways to add to 8. It's the 2, 6, 3, 5. That's not 3, 6. That's not 5. So these adding to 8, we could do 2 with 6 or 5 with 3. Okay, and so now that we know this adds to 8, this does add to 9, meaning this is a 4, 5 pair, meaning that actually has to be the 2 with the 6. That's not 2, 6. This is 3, 5. 3, 5 pair, and then that tells us what this is. This is 1, 2, 6, which is 9. Wow, okay. That might have taken me longer than it should have, but that was fun to go through. This is a pair. This is 1, 3. So what can I do with this? This black dot, if this was a 1, this would be a 2. If this was a 2, it could be a 1 or a 4. If this was a 6, it would be a 3. I don't think there's a lot going on with that. Actually, we can't. Oh, no, we can do 1, 2. I was thinking about how it would affect this cell, but no, I was thinking about it wrong. 3-5 pair makes this a 6, that a 5, and that a 6. Okay, so that's not a 6. 3-5 makes that not a 3, I guess. All right. So these two add to 6. Let's pencil these, actually. We need 1, 3, 5. So we can't put a 3 on here to add to 6. That's not going to work. And so this is going to be a 1-5 pair no matter what. Meaning that's not 1. 2, 3, 4 is what's left. The row. This can't be 1 or 5, so that's a 3. That's 5 and 3. That's 1 and 5. Okay, that's big. 4 and 1. 5 and 3. 2, 4, 1. 3 in the corner celebrating. That's not a 1. That's not a 3, so that's not a 6. 1, 2 pair puts the 6 there. This column finishes with a 2. That's 4. 4 goes with 2. That's 1. That's 2, 3, 1. We get the 3, 2, 1 here. This is our 4. Hopefully this adds up. That's 10. That's 10. Perfect. This is a 5. This is a 6, and we're done. All right. Did I use this line? I don't remember this line here. Did I actually do any logic with it? I don't remember. It's interesting. Cool. So it makes me think that maybe there was something easier to do up here, but thinking about this box was really interesting. I enjoyed that. Cool. Well, nice puzzle, ChinStrap. And I know that there is a blue side B, which is interesting, but I'm not going to tell you why it's interesting until we feature that later. So you'll have to stay tuned. Definitely enjoyed this. Let me know how you did. If you enjoyed it, why not leave a like, subscribe, and a kind comment below.